This video will be discussing ways to design multimedia instruction to minimize extraneous overload. Extraneous overload occurs when the essential cognitive processing and the extraneous cognitive processing are greater than the cognitive capacity of the learner. There are 5 principles used to design multimedia instruction to avoid extraneous overload. They are coherence, signaling, redundancy, spatial contiguity, and temporal contiguity. These principles are based on the cognitive theory of multimedia learning. We will be going over 3 of those principles today: coherence, signaling, and spatial contiguity. The coherence principle states that learning is improved when material that is not relevant to what is trying to be learned is excluded rather than included. The coherence principle is used when the essential processing and extraneous processing is exceeding the cognitive capacity of the learner. It will be used to minimize the extraneous processing by eliminating material that is not relevant to what is being taught. This includes things like stories about the material, personal experiences with the material, etc. This does not mean that those things cannot be included. It just means that the instructor needs to be intentional about including those things, so they are at times when the essential processing is at a minimum, so the extraneous processing for the things like the stories does not overload the cognitive capacity of the learners. Both the images below show an example where the coherence principle was applied and where it wasn't. Both these relate to teaching the ideal mechanical advantage of levers. The image on the left would not use the coherence principle, because even though a seesaw is a type of lever, the image doesn't have anything to do with what the ideal mechanical advantage of a lever is. The second image uses the coherence principle, because again it is a picture of a lever, but this one has information relevant to finding the ideal mechanical advantage. Research suggests that the coherence principle has a larger effect for students who have low working memory capacity. It is also more effective if the pace of the learning was set by the instructor rather than the student. Research has also indicated that the more interesting the extra material was, the more benefit will be created by removing it. The coherence principle is directly related to the cognitive theory of multimedia learning and the cognitive load theory. The ideas of essential processing and extraneous processing are analogous to the ideas of intrinsic and cognitive load from the cognitive load theory and to the extraneous and central processing from the cognitive theory of multimedia learning. The coherence principle also relates to the cognitive theory of multimedia learning because it discusses both verbal and graphical channels that can be overloaded when the essential processing and the extraneous processing are greater than the cognitive capacity. We'll now move on to the signaling principle. The signaling principle states that people learn better when visual cues are added to highlight the material that is essential to learning. The signaling principle is again useful when the essential processing and the extraneous processing are greater than the cognitive capacity of the learner. The method for using the signaling principle is to simply use something like arrows or highlighting relevant information in text or images. It is important that the signaling does not add any new information. The image below is an example of using the signaling principle. The arrow below is to point out a cirque formed by a glacier. This is a good example because it's highlighting something the learners are unlikely already to know. Research suggests that the signaling principle is more effective for low-knowledge learners than for those with high knowledge. It is also more effective when it is used sparingly rather than being overused. The signaling principle is related to the theory of multimedia learning and the cognitive load theory, again through the idea of essential processing or intrinsic load, and extraneous processing or extrinsic load. The essential processing is managed by signaling, especially when there's a lot of interacting elements, because it shows the learner what to pay attention to at any given time. Extraneous processing is minimized, again by showing what to focus on, and avoiding the learners focusing on material that is not related to what is supposed to be learned. Lastly, we have the spatial contiguity principle. The principle of spatial contiguity is the idea that people learn better when words and the pictures they are related to are near each other in the presentation. The main goal of using spatial contiguity is to reduce the extraneous overload that is caused by layouts that are confusing or that require processing to match words with pictures. So according to the spatial continuity principle, labels should occur within the diagram as opposed to a key or legend that appears off to the side of the image. When making use of images associated with words, be sure to minimize the distance the viewer needs to move their eyes to determine what the label refers to. The two diagrams below highlight the principle of spatial contiguity. The image on the left has less extraneous processing because learners do not have to scan the page for the relevant information. It is labeled on the heart diagram. The image to the right introduces extraneous processing because it forces the learner to scan the page for the relevant information about the heart. Research suggests that the spatial continuity principle is most effective when it's used with learners who have low prior knowledge. Research also suggests that the principle is most effective when used with complex lessons that are in interactive formats. Lastly, the research suggests that the principle of spatial continuity is most effective when the words referring to the images do not give information that can be gained from looking at the picture alone, because it violates the redundancy principle, which is one of the 5 principles we will not be discussing today. The spatial continuity principle is related to both the cognitive theory of multimedia learning and to cognitive load theory, again through the idea of extraneous processing or extrinsic load. The goal of the principle is to reduce the effort required to scan a page, which adds extraneous processing to any presentation.